Okay, today in this lesson we will study what is oxidation and reduction. Second, the concept of oxidation state, oxidation number. Third, how to determine the oxidation number. And the last, identifying redox reactions. That we will have a very complicated reaction, and in that complicated reactions, with the help of oxidation number method, we will able to identify that reactions are redox or not. Now moving toward our first, that what is oxidation and reduction. When we talk about the oxidation, there are three definitions of oxidation. The first definition, the loss of electron, and when any substance lose electron, the oxidation state increases. Okay, the second definition is the addition of oxygen, and the third definition is the loss of hydrogen. Focus on the example. In this example, you can just focus on the left hand side, zinc. Initially zinc has a zero charge on a left hand side, but now on a right hand side it acquires 2 plus charge, so it means it has lose electrons. When any substance lose electron, the term is called oxidation. Just focus on the reduction. If you remember, if you understood the oxidation, then you also understood the reduction, because the reduction is opposite of oxidation. Reduction will be the gain of electron or decrease in oxidation state, opposite to the oxidation. Similarly, the second definition would be the loss of oxygen, and the third definition would be the addition of hydrogen. Okay, now focus on the same example. Now just focus on the copper. On the other hand, previously copper had a plus 2 charge, but after reaction it requires a 0 charge. It means it is gaining electron because its oxidation state is decreasing. So I would say that is called reduction. Now this was the oxidation reduction. Moving toward the next step. Now we will discuss the oxidation state. What is oxidation state? Oxidation states are the number basically assigned to an atom that reflect the net charge on atom. In the previous examples you have seen that copper contain plus 2 charge. So basically these kind of numbers are called oxidation state. As the oxidation states are generally numbers, so basically we can also say them as a oxidation number or ON. Okay, to how to determine these oxidation numbers, there are some rules. Now I will explain what are the rules. Moving toward the rules, the oxidation number of a simple ion is equal to its ionic charge. For example, there are, now you can see there are three ions: sodium ion, copper ion, and nitrogen ion. And you can also see a charge on that. Sodium carry positive plus, only single charge. On the other hand, copper contains 2 plus charge and nitrogen contains 3 minus charge. So that would be their oxidation number. Simple. Plus 1 for sodium, plus 2 for copper, and 3 minus 3 for the nitrogen. This is the simple way. Whenever you see any ion, the charge will basically reflect, or charge will indicate the oxidation number. Okay, now moving toward the second rule. Just remember that the oxidation number of hydrogen is always plus 1, because with the help of oxidation number of hydrogen we will able to calculate the other oxidation number. Okay, according to this rule, if we say that oxidation number of hydrogen is plus 1, then chloride must have minus 1 charge to balance it. So this is the way we will able to determine the oxidation number of other elements too. Now moving toward the third rule, the oxidation number of oxygen would also be the minus 2. In the example of H2O, oxygen always have minus 2 charge because 2 positive hydrogen are attached to it. Now moving toward the fourth rule, the oxidation number of an uncombined element or diatomic molecule is always 0. And let's see an example. Right now you can see sodium, copper, and nitrogen. You can see there is no charge on that and they are pure. So the oxidation state of sodium, copper, and nitrogen, right now they will have oxidation number of 0. Okay, now the fifth rule, for any neutral zero charge compound, the sum of oxidation number is always 0. Now this is an example. In this example, this is the example of carbon dioxide. So you can see there is no charge, it means the total charge would be equal to 0. Now there are two oxygen, then one oxygen can carry -2 charge, then -4 charge be there will be -4 charge on 2 oxygen. Now to balance -4, what should we write here on a carbon? So according to the rule we must write +4. So that is the way we will able to write down the oxidation number of the other elements. Now moving toward the next rule. Previously we have just discussed the neutral substance. Now let's talk about the complex ion. If you just remember, ions always contain positive or negative charge. So according to this rule, for a complex ion, the sum of the oxidation number is equal to the charge of complex ion. Okay, now you can see in this example it carry -1 charge. So initially I will write -1. Now after that I will write the oxidation number of the known element. Right now I know what is the oxidation number of oxygen. Oxidation number of oxygen is -2 and there are 4 oxygen. So I will write -8. Now what should I write in place of manganese to get answer -1? I should write +7. Now this is the way we will able to identify, or we will able to determine the oxidation number of other elements. Now we will discuss the last part of our lesson today, identify redox reaction. Okay, number one thing we have to understand that oxidation and reduction always occur together, and these reactions are called redox. Okay, there are so many different ways to identify redox reaction, but the best way is to look for the change in oxidation state. Okay, now let's understand this with few example. Okay, how we will able to understand that which substance is undergoing oxidation and which substance is undergoing reduction. So we have to write down the oxidation state of every element. Okay, right now let's talk about chlorine. First I will write down the oxidation number of chlorine, that is -1, but there are 2 chlorine. So the oxidation state would be -2. To balance -2, the tin must have +2 oxidation state. Similarly, if you just focus on this example, in this example there are 4 chlorine. One chlorine acquire -1 charge, -1 multiplied by 4. So actually it has -4 charge. To balance -4 charge, lead must have +4 charge, or you can say the oxidation number of lead is +4. Okay, moving toward the right hand side of this reaction, there are 4 chlorine attached to single tin, and similar to the previous, that tin must have +4 charge because there are 4 negative -1 attached to single tin. Similarly, when we talk about the lead, now there are 2 chlorine attached to a single lead, then lead must have +2 charge. Okay, now just focus on lead and tin. Now you can see that the oxidation state of tin has changed, +2 to +4. So what is happening here? Is it increase or decrease of electron, or it is increase in oxidation number? So basically you can say that there is an increase of +2 charge. Okay, in short we say electron has lost. Loss electron means oxidation. L loss, E electron, O oxidation. So oxidation is happening here. Similarly, when we focus on the lead, so on a lead opposite thing is happening. Gain electrons mean reduction. So lead is gaining 2 electron and tin is losing 2 electron. Now let's talk about the second example. In this example, first we need to write down the oxidation state of any element. So starting from the first, in the first we have copper sulfide. In copper sulfide, sulfur has oxidation state of -2. To balance -2, copper must have oxidation state of +2. Similarly, right now we have in the second we have H plus ion. H plus ion has a +1 oxidation state. Okay, now this is NO3. We name this ion as nitrate ion, it already contains -1 charge. So we have to write down the oxidation state in such a way that we get -1 as answer. Right now we have 3 oxygens. One oxygen contains -2 charge, then -2 multiplied by 3, the oxygen state would be -6. Okay, now we have to write down a number. When it's subtracted by -6, we should get answer -1, so +5. So right now this is the oxygen state of nitrogen. Now moving toward the product side. In product side, copper ion contain +2 oxygen states. And when we talk about this sulfur, now focus on this sulfur. This is in a free state. So when a substance in a free state means it is not combined with other element, it is in a pure form, so it must have oxidation state of 0. Similarly, now moving toward NO. In NO, oxygen must have -2 of oxygen state. To balance it, nitrogen must have +2 oxygen state. Similarly, when we talk about water, in water oxygen must have -2 oxygen state, and we already know that hydrogen has +1 oxidation state. Now what we will going to do, we will going to check which element oxidation state has changed. When we talk about, let's focus on the first, sulfur. Initially the oxidation state of sulfur was -2, but it has changed to 0. And when we talk about the second one, in the second we can see the nitrogen has the oxygen state of +5 and it become +2. Now where the electron are being lost and where the electron are being gained, when we talk about the nitrogen side, nitrogen oxidation number is decreasing, so it means gain of electron. So we will say GER, gain electron means reduction. On the other hand side, sulfur is losing electron and it is losing 2 electron. So L we will basically represent in short LEO, L lose, E electron, O oxidation. Now this is the way we are able to identify where the oxidation is going on, where the reduction is going on. And okay, last thing I want to explain that a substance which undergo oxidation right now, this one is undergoing oxidation. A substance which undergo oxidation is termed as reducing agent. And similar to that, the substance which undergo reduction or in which reduction is going on is termed as oxidizing agent. Oxidizing agent. Now with the help of these redox reaction, you can also identify which are reducing agent and which are oxidizing agent. Now that's all. Thank you.